Hello, everyone. It's Miss Elizondo, and this week is 2.4. So, this video is going to help you update your science notebook. So, let me show you my science notebook. I'm using fourth period again. So, this is my science notebook. If I open it up, you'll see my syllabus. So, it is for week 4 in science for reporting period 2. It gives me the expectations, it gives me what I need to learn as a fifth grader, what I'm responsible for. I have Monday, Tuesday, Wednesday, Thursday, and Friday. Okay, so we do notes, we make notes on what we're going to be doing this week. But in my science notebook, I have for week 2.4, force and motion. So this week we're studying about force and motion. So these are the vocabulary words for force and motion. Force is a push or a pull, so we drew a wagon. Spring scale, this is what we drew. It is yellow on mine, it is blue in your fusion book. Okay, and it is a tool used to measure force in newtons for the gravity part. It also measures grams or mass in grams. We have weight is a measure of the force that gravity exerts on an object. So yes, when you go to HEB and you are paying for a bunch of bananas, you use the scale and it is measuring the weight you are paying for gravity on this earth plus the bananas. Okay. The next word is friction. So I drew a football cleat or the shoes that you wear when you play football. It's a force that opposes motion between two objects that are touching. So, why do we wear cleats? Because we want our foot to stay firm on the ground. We don't want to slip during football. Okay, so we want friction. We have balanced forces, forces on an object that are equal in size and opposite in direction. So, I think of a tug of war. We have two people on one side, two people on the other side, both same size, same shape, same weight. So it's a very boring tug of war. But if you have an unbalanced force or unbalanced forces, you have two people on one side, four people on the other, and then you see the action. So someone's going to lose. Maybe it'll be the one with four, maybe it'll be one with two. It depends, but they're unbalanced. So they're unequal on both sides. Then you have the word gravity. And I drew you falling off of the trampoline because when you bounce too hard on the trampoline, you do go up and oh, it's fun. And then gravity will pull you down. Okay. So it is a force of attraction between two objects, you being one of the objects and Earth being the other. Okay. You're going to fall back down to Earth. Movement is motion. So I drew like when you're playing pool, when you have to really plan out how you're going to hit that ball on the pool table. And it depends on where you hit it, it has a different angle on where it's going to go. Okay, so that is movement or an example of movement, but you can draw yourself dancing. That's also an example of movement. So these are all of the vocabulary words for this week on force and motion. Then I turn the page and I'm on a clean page. Okay, and I'm going to turn my notebook so it is laying down or it's landscaped. Okay. So at the bottom, right below the pink line, I wrote the title scientific method because we are setting up our notebook so that we are ready for the experiment on Thursday. Okay. But we're going to follow the scientific method. It is a process in which scientists follow. Okay. Every single step that scientists do in every experiment that they perform. Okay. So how do I get this little three-sided board? It looks like a science fair board. So this is a mini version of it. Okay. So once you write your title, scientific method, I'm going to count 8 lines. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to trace with my black marker all the way up. On this side, I only skipped 4 lines. 1, 2, 3, 4. And then I traced a black line going all the way up. Okay. And then on the bottom, I traced it with green marker. So green means go. You're going to cut on the green line. You're going to do the same thing on the other side with the green marker. I traced it so I know where to cut. I'm going to cut all the way till I get to the black line. Okay, and that'll give me these two little doors here. So if I fold it on the black line, I have a mini three-sided board ready for my science project. Okay, but on a mini version in your notebook. So when I open it up, I placed the proper method where it's supposed to go. So your title of your project has to go here. It can't go over here. It can't go over here. It has to be here at the top in the center of your three-sided board. So I started writing, which surface will allow my toy car to move the farthest? Okay. So then I moved over to problem because that's the first step. What's the problem that we're going to have? Well, that is the problem. You want to find out which surface will allow your toy car to move the farthest. So I just copied it all over again. Then I answered the question. I answered my own problem with my hypothesis. And this is done before the experiment. So I think that smooth surface will make my car move the farthest. Okay. So I chose the smooth surface instead of a rough surface because in my background science knowledge, I know that when my mom is driving the car, especially in front of Eisenhower, there's bumps there and she slows down and goes over the bump. So I know that it's not very smooth. Therefore, the car runs slower. Okay. And I don't go as far as fast. So that's my background knowledge for my hypothesis. Then, Miss, what are we going to need for our experiment? For sure, you're going to need your toy car. And this is the one I'm going to use and I have been using for the past 4 weeks. Okay. You're going to need a smooth surface. So you can use your desk or you can use your floor. The rough surface, you're going to have to use a carpet or you're going to have to use a rug or you're going to have to use a blanket, something that is rougher than your floor. Also, you're going to measure the distance your car travels. So if your car travels 12 inches, you got to know that with a ruler. Or if you don't have a ruler at home, you can use measuring tape or tape measure. But Miss, I don't have either one. Well, then you're going to have to use your foot. Okay. Your foot's about 12 inches, or a foot is about 12 inches, not always 12 inches, but it's not going to be approximate. It's not going to be accurate, but it's approximate. Okay. So you do want to measure something, measure the distance your car has gone. So this is the first part of the project. Okay. On Thursday, I'm going to tell you the steps to doing this project. And then you're going to have to write down what happened. These are your observations. So you have the surface, smooth and rough. So all I did is I wrote the word surface and then I drew a line going down. And then I wrote distance because you're going to have to record how far your car goes. Okay. So I wrote distance. And how many surfaces? I only have two, smooth and rough. Okay. How many times am I going to do this experiment? 3 times or more. Okay. So you're going to test your car on the smooth surface one trial, the second trial, and the third trial. And the trial means you're going to try 3 times with a smooth. You're going to try with a rough surface. Okay. So once we are finished with the experiment, you have your data here, and these are where you're going to put the results. Well, what happened? Which surface was the best? Okay. Was it the smooth? Were you right or were you wrong? Why? So these are the results. And then you're going to draw a conclusion. Well, why did that happen? Why do you think that happened based on your data? Okay, you're going to write a conclusion and also explain why you were wrong or why you were correct. And then you're going to think about, well, why am I doing this project? It's an application. How does my project help in real life? So this is a real life example of how can my toy car with smooth and rough surfaces be applied in real life. Okay, so you can even think about the Indy 500, you can think about race cars, you can think about your own car, your mom's car, how it runs on a smooth surface, how it runs on a rough surface. That's how it applies in real life. So this is your mini trifold or your three-sided board for your experiment on Thursday. Okay. And you have your vocabulary for this week. So this is the update for week 2.4, force and motion. Thank you.